We're assuming that each output unit that's produces delta units of carbon dioxide pollution, and that every pollution voucher entitles the holder of the voucher to produce 1 unit of carbon dioxide pollution. In panel B, we therefore convert the output units from panel A on the horizontal axis to pollution units in panel B, with vouchers then defined over pollution units. Since every output unit results in delta units of carbon dioxide, the horizontal intercept A over alpha in panel A becomes delta A over alpha in panel B. Similarly, any marginal cost or marginal benefit of an output unit will now be equal to that marginal cost or marginal benefit divided by delta on the vertical axis, thus changing the intercepts on the vertical axis from A and B to A over delta and B over delta. The 3 market output quantities xm, x2, and x1 in panel A then become delta xm, delta x2, and delta x1 in pollution units in panel B. Since the demand and supply curves that give us the marginal cost and marginal benefit curves in panel A are linear, the marginal cost and marginal benefit curves in panel B will also be linear, and we can derive their slopes from any 2 points that we've graphed. We can also see them, as well as the intercept terms, in the equations 21.11 and 21.12. In panel A, we imagined how much producers would be willing to pay for the right to produce 1 more unit of output if output was restricted to x2 or x1. In panel B, the analogous vertical distances represent the amount that firms would be willing to pay for the right to emit 1 more unit of pollution, given that the government has restricted output to either x2 or x1.